Algebra 2, Chapter 9.2, exercises 13 through 20. In this exercise set, we're going to be working with rational functions, translations, rational functions, and specifically I'm going to do in this set problems 13, 15, 17, and 19. Rewrite the function in the form g of x equals a times 1 over quantity 1x minus h plus k. And what I'm going to do in this exercise set is work it in this form here. And so instead of using 1 over b down below in the second version, I'm going to stick with this form and leave it with a. Just, I think, keeps things simpler that way, because then it becomes, in terms of vertical stretch or compression. I'll still state the domain range using inequality, set notation, interval notation. And so here, what we're going to do is something we've done recently in this class, is use division. In this case, we can use synthetic division pretty easily. So if we go ahead and take this linear binomial, we can put up here 3 and negative 5, and we're going to divide by the 0 in the denominator, which is 1. And I hope you've done this recently enough to really see what's going on. So you bring down the 3. So 1 times 3 is 3. Negative 5 plus 3 is negative 2. So what we get here is 3 minus 2 over x minus 1. Okay, so what this becomes is, in the form, so we're going to write this as g of x equals, in this form we're going to put negative 2 times negative 2, and we'll put over here times quantity 1 over x minus 1, and we put out here plus 3. So this is the form. So we have k, or h and k, because this form x, so the center is going to be the point h comma k, which in this case is going to be 1 comma 3. So I put the center over here at 1, 3. So that's our center, which will determine our horizontal asymptote and our vertical asymptote. And then we have this, we have negative 2 over x minus 1. Well, this is going to be a reflection about the x-axis, and also a vertical stretch by a factor of 2. So if we had, normally we'd be here and here, well, we're going to reflect about the x-axis and vertically stretch, so by a factor of 2. So we're going to be coming like this. And then over here, because we would be here at normally at 1 left and 1 up with a vertical stretch of 2, we're going to be like this. And you can verify what that is by making a table. And we have x, g of x. So if we plug in Actually, I'm off by 1 here because we had to go left. 1, up 1, so it's going to be like this. There we go. So if we use a table here, xg of x, and we plug in 0 for x, and then 2 for x, we're going to be able to have our points here to sketch with these asymptotes. So if we plug in 0, we can use this form up here if we want to. G of 0 is going to be -5 over -1, which equals 5. And so that's what we have here, right? And if we plug in 2, we get 3 times 2 minus 5. So that's going to be 6 minus 5, or 1. And then we have 1, 2 minus 1. So we have 1 over 1, which equals 1, which is what we have here. So that verifies. And then state the domain and range. Our domain is going to be, using inequalities, we have x is less than our vertical asymptote of 1, and also x is greater than 1. Our range is going to be y is less than, looks like 3, and also y is greater than 3. And then set notation, x such that x is element of all real numbers, except x cannot equal 1. And then our range in set notation is going to be y such that y is an element of all real numbers, except y cannot equal where our horizontal asymptote is. Y cannot equal 3. And finally, in interval notation, we have domain. We have greater than -infinity to less than 1, union, greater than 1, less than positive infinity. And our range can be very similar. We have y is greater than -infinity up to less than 3, but greater than 3 to less than infinity. So that would be our domain and range. In inequality, set and interval notation. Okay, let's see here. I'm sure we get this better outlined. There we go. That looks a little better. Next on our problem, which is 15, we have, I want to just show you here, we got this 0.5 here in the denominator. That's going to be a little bit of a complication. One thing we can do here is if we multiply both our numerator and denominator by 2, okay, then 0.5 x plus 2. What that will do is that's going to turn us into 2x plus 10 over, we have x plus 2 down here. So that could make your life easier. Number 14. Number 15, same thing we've done in problem 13. We can synthetically divide. So we put 11 here. And we bring our 0 out here, which is 2. Bring down the negative 4. 2 times negative 4 is negative 8. 11 minus 8 is 3. So we have negative 4x plus 3 over x minus 2. Now I got that wrong. It's going to be negative 4 plus 3, not negative 4x. So we can write this as g of x equals 3 times 1 over x minus 2 minus 4. So in this case, for our center is going to be the point h comma k, which is going to be 2 comma negative 4. So we mark 2. So I'm making our vertical asymptote at x equals 2. And then our horizontal asymptote at y equals negative 4. And then we have a equals 3. So what that's going to do, and this is going to be positive 3, so we take our 1, 1, and we stretch by a factor of 3, so this translated 1 comma 1, which would go down here, will go up 2 more. So we're going to go through this point here. And by the symmetry, we're going to also go through this point over here. So it's going to come like something like this. I'm having trouble getting this right. There we go, something like this. Yeah. And then over here on the negative side, we're going to come over here and over here. So we're coming like this. So that's what it's going to look like. And again, we can try we shift it over to the right, so we can use 1 and 3. So if we use g, we use x, g of x, and we use 1 and 3. And we can try up here, we put in 1, we get negative 4 plus 11 over 1 minus 2. So we're going to get 7 over negative 1 equals negative 7. And see, that's exactly what we have here. See that? And if we put in 3, we get we'll get negative 12 plus 11, or 1, over, let's see, that's going to be negative 1 over 1, or negative 1. So negative 1, which we got right here. See? So we have 3 comma negative 1, and we got 1 comma negative 7 over here. Okay, we get to our domain and range. In quantitation, we have domain, we have x is x is less than 2. And also we have x is greater than 2. For our range, we have y is less than -4, and y is greater than -4. In our set notation, we have x such that x is an element of all real numbers except x cannot equal 2. And then we have for our range, we have y such that y is an element of all real numbers except y cannot equal -4. And then for the last thing we're going to do is go to our interval notation. Domain, x is greater than -infinity, less than 2. Union, greater than 2, less than infinity. Range, we have the same type of thing except we have less than -4. Union, greater than -4 to less than infinity. And that's going to be it. Okay, next. We have write the function whose graph is shown. And we have, this one should be a little bit easier than the last one we did, because we have a center here, which is a point 3, 4. And then as far as what we stretch by, it looks like it's going to be stretched by a factor of 3, because instead of 1, 1, we're up here at 1, 3. So g of x equals 3, and that would be our a form, over 1 times x minus h. Well, the point h comma k in this case is going to be 3 comma 4. So x minus 3 plus 4. And so that should really be it. And we could test. If we test, for instance, 5 and 2, we should get our values right here. One way you could do that is you can leave this blank and put in the values. In fact, I'm going to do it that way. If we just leave a blank, we have g of x. This will just be a test at this point. Leave a blank, and then we have 1 over x minus 3 plus 4. I'm just going to test one of these. We're going to put in the point 4 comma 7. So we have 7 equals a times 1 over, in this case, x is 4. 4 minus 3 plus 4. We're going to have 7 equals 1 over 1 plus 4. And if we subtract 4, well, that's going to be a over 1. A over 1 plus 4. Subtract 4. A is equal to 3, which checks, and we can check our negative, our other point down here. And so that would be it for number 17. Okay, now 18, I recommend going about doing the form. I recommend using the form A times 1 over x minus h plus k. Okay, that's just what I would recommend. Okay, 19. Again, I'm going to use this other form. The center is going to be at the point 3 comma negative 1. So 3, negative 1. And so writing that out, we have g of x equals a times 1 over x minus 3, and we have minus 1 on the outside. And now taking the point 3.5 comma 0, let's go put that in place. So 3.5 equals a, which we don't know yet, over 1, and 1 over, and x is going to be 3.5, excuse me, I got this backwards here. We have 0 is equal to, and then we have a times quantity 1 over 3.5 minus 3 minus 1. So what we have here is we can add 1 to both sides here. So we have 1 equals a times 1, and 3.5 minus 3 is 0.5, and 1 over 0.5, or 1, I'll put aside over 1/2, equals 1 over 1 times 2 over 1 equals 2. So here we have 2a. So if we take 1 equals 2a, a is equal to 1/2. So what that becomes, I'm just going to work to the right up here. We have g of x equals 1/2, which is what a is, times quantity 1 over x minus 3 minus 1. So that's going to be our answer here. And then number 20, can find the center point just from there. I think we're going to have a reflection about the x-axis. Anyway, it's a procedure. I hope this has been helpful to you. Good luck. Work with your teacher. Thanks for viewing.